Hello everyone, in today's class we're going to look at an important concept in fluid mechanics, which is pressure. Now pressure can be measured in two ways. It can be measured in absolute, where the pressure is referenced to zero, and it can be measured in gauge pressure, which the pressure is referenced to the local atmospheric pressure. So if you're measuring a car tire's pressure in Vancouver, your local reference will be Vancouver at that specific time. Whereas if you're measuring a car's tire in Toronto, your local pressure will be Toronto at that specific time. So to help you understand that better, let's take an example of a car tire. Okay. The pressure in that tire here is 30 psi. 30 psi. Okay? That's the gauge pressure, because it's not taking into consideration the outside pressure. So that's the gauge pressure. If you want to convert that from gauge to absolute, what would end up happening is pressure of the tire will equal to the gauge pressure, meaning the pressure inside, plus the atmospheric pressure, which is the standard pressure. So the standard pressure is 101 kPa, okay? Or in different units, it could be 14.7 psi. psi. Okay, so the tire pressure, the pressure of the tire in absolute, this is absolute, will be gauge, which is 30 psi plus 14.7, which is the pressure outside, or the standard pressure. Therefore, the pressure of the tire equals 44.7 psi absolute. You have to specify that it's absolute, because if that absolute is not specified, people by default will understand it's the gauge pressure. Okay? So let's draw a diagram to help us understand it even further. So we'll say this line here is where P equals to 0, absolute. So the absolute pressure is 0 here. Okay? The second dashed line is the standard temperature, pressure or atmospheric, which P equals 101 kPa, or 14.7 psi. Okay, now we want to find PA. Okay, they told us that, hey, PA is 200 gauge. PA equals 200 kPa. Gauge. If the gauge is not specified or absolute's not specified, by default it's gauge, but I'm gonna write it anyway. Gauge. Okay. Now we're asked to find the pressure of A in absolute. So we'll start from 0, because the absolute has a reference point of 0. 0. We'll go all the way until we reach standard, which is the atmospheric pressure, plus the 200. Therefore, PA equals 200 kPa, which is the gauge, plus the atmospheric, which is 101 kPa. Therefore, PA equals, by the way, this is absolute. We're calculating the pressure of A in absolute. The absolute pressure of A. Therefore, PA equals 301 kPa absolute. Again, if you're measuring the absolute pressure, you have to specify that this is the absolute pressure, because if you don't, by default, it's assumed to be gauged. Now, one other thing I forgot to mention is that the gauge pressure could be negative or positive. Usually when it's negative, it means that it's a vacuum. Okay? Whereas the absolute pressure cannot be negative because it starts from a reference point of 0. Okay? So let's do an example with a negative. We'll say PB is negative 50 kPa, meaning it's a vacuum. That's the gauge pressure. Okay, now we're asked to find the absolute pressure of B. Again, we have to start from a reference point of 0. We'll go all the way up. Therefore, the absolute pressure of B, the absolute pressure of B equals, well, we know that the atmospheric is 101 minus 50, we'll get the absolute. Therefore, 101 kPa minus 50 kPa. We'll get 51 kPa absolute. You have to specify that it's absolute. So I hope this diagram helped explain the difference between absolute and gauge pressure. In short term, gauge pressure is the pressure of that is the pressure in a certain, not including the atmosphere of that location at that time. Whereas the absolute pressure, it's including the pressure of the atmosphere and the pressure of the item, if that makes sense. Okay, let's move on to an example. We'll say, example says that we have a snow sled that is traveling with a given velocity, right, over a body of water. So this is the ice, that's water, and we're asked to find the thickness of that body of water, which is D. Okay, we're assuming that the velocity profile of the snow sled is linear. At the surface of ice, the velocity is 0, which could also be called no slip, meaning that velocity at the surface is 0, and as we move away from the surface, the velocity increases till it reaches its highest point. Okay, we're asked to find D, and we're given the force, which is 1.3 newtons. We're also given the velocity of the snow sled. The force is the force used to push off the sled, and plus the acceleration as it's moving. So the current force at that moment. Okay, the velocity it's traveling with, which is 50 meters per second. Area of the body of water, which is 0.08 meters squared. And the viscosity of water, which is 1.3. Let me rewrite this. Mu equals 3.5 times 10 to the power of negative 5 for Newton seconds per meter squared. And we're asked to find d, which is the thickness or the height of that body of water. Okay, so from the previous class, we know that shear stress equals viscosity times the velocity gradient, which is du dy. And since the velocity is assumed to be linear in this example, du, this term here, can be changed to change in velocity divided by change in y, change in height. Okay, and let me make this a little smaller. Therefore, it will be final velocity minus the initial velocity, which is 0, because we're assuming that the velocity at the surface is 0, no slip, divided by the final height, which is d, minus the initial height, which is 0. Therefore, we can say that shear stress equals viscosity, mu, times the final velocity, called the final velocity v, as given in the problem statement, v minus d. Okay, now we have the velocity, we're looking for the thickness, we have viscosity, we don't have shear stress. From the previous class, we know that shear equals force divided by area. We do have the force and the area, which are given here. Okay, so let's substitute our numbers. Before that, we'll substitute this into the equation. We'll say that F over A equals viscosity times velocity over d. We'll substitute our givens, which is 1.3 divided by 1.3 newtons divided by 0.08 meters squared equals 3.5 times 10 to the power of negative 5 newtons per second meters squared. Make sure you put in the units, times 50 meter per second over d, which is meters. Okay, we'll end up having a d value of 11.7 times 10 to the power of negative 4 meters. And that's your final answer. That's the thickness of water. Whenever you find yourself working on a problem during the exam or an example, make sure you make a drawing of the problem statement. It acts as a delay to your brain to think while you're drawing the problem, which is an efficient way of solving problems. Okay, see you in the next class. Bye.